So now we're going to have a look at scaling the mean and the variance for a discrete random variable. So here we're back to our ice cream shop, but they're going to start doing a super saving Sunday where all the prices are being halved. So we can see here that instead of 50p it costs 25p for one scoop, instead of 90p it costs 45p, and so on, but the probabilities have stayed the same. So what are we going to expect to happen to the expected value of the cost? Well, because he's selling everything for half the price, we'd probably expect for the prices to be halved, so we're expecting it to decrease. Okay, you can be more specific and put halved as well. For the variance, well, it's a bit harder to say what's going to happen to that, but if we have a look at the values, we can see here that we're going from 50p to £1.60, and here we're going from 25p to 80p. So these values, the new Super Scoop Saturday values, are closer together, so we're expecting the standard deviation to decrease, which means that we're expecting the variance to decrease because our values are closer together. So now we're wanting to calculate the new expected value, and we're having a look at how this compares to the original one. So I've copied the original value over from my example on the previous part of finding mean and standard deviation of discrete random variables. So we're having to look at the sum of x, p of x equaling x, which, remember, we do by doing the outcome times the probability. So 0.25 times 0.4 plus 0.45 times 0.16 plus 0.65 times 0.24 plus 0.8 times 0.2. Now we can put that into our calculator. 0.25, sorry, typing in the wrong part. 0.25 times 0.4 plus 0.45 times 0.16 plus 0.65 times 0.24 plus 0.8 times 0.2. And there we end up with our expected value of 0.488. Now I'm going to show you a quick way to have a look at this. If you went into the stats function, and in this one, if you put the costs of the ice cream, so our 0.25, our 0.45, our 0.65, and 0.8, and you can see I've already put the probabilities into the list too. Then if we go to calc, make sure our set says list 1, list 2, like we did when we had frequencies. When we click on one var, we can see there that the mean is coming up the same as when we use the formula. So this works if it's just a quick 1-mark question saying to find the expected value. If it's a show that question though, we need to be able to show that formula, so make sure that you do practice with it. So the second part of this question is asking us to compare our new value with our existing one. So we now have 0.488. If we divide that by our old value of 0.976, we get a half. So that shows that this is half of the original value, the original mean. Now it's wanting us to do the same with the expected value. So this time we're doing the sum of x squared, p of x equals x for our sum of x squared, for our e of x squared even, sorry, which is part of our variance formula. So for that, I am going to cheat a little bit because we're going to have to use this again. So just to speed things up a bit, I've got 0.25 squared times 0.4 plus 0.45 squared times 0.16 plus 0.65 squared times 0.24 plus 0.8 squared times 0.2. So that's the outcome squared times the probabilities, which gives us 0.2868. That's our E of x squared. Then we need to subtract our E of x, so our 0.488 squared. So 0.2868 minus 0.488 squared gives us 0.048656. And when we have a look at what's happened there, if I divide that by my original variance, which I've copied over and put here, this is my original variance here. So dividing it by 0.194624, we've ended up with a quarter. So this is a quarter of the original variance. So I'm going to give you a moment now to try the now you try question, and then I'll go through it on the video. So please pause now and give the now you try a try. Okay, so hopefully you've given the now you try a go. This time the owner of the ice cream shop is going through a rich part of town and he's going to double all his prices. So that means that 1 scoop is now going to be £1, 2 scoops is going to be £1.80, 3 scoops is going to be £2.60, and 4 scoops is going to be £3.20. So it first asks us to fill in the table, which we have done, and then it asks us to calculate the new expected value. So remember that we can use the shortcut way in the stats table because it's only asking us to figure it out, it's not a show that question. So remember that the new price for 1 scoop is £1. For 2 scoops, it's £1.80. For 3 scoops, it's £2.60. And for 4 scoops, it's £3.20. Sorry, £3.20. Making sure your set says list 1, list 2. There we go. We have our mean cost, which is £1.952. The original mean again I've copied over so we can see what's happened here. Let's have a look. So if I do 1.952 divided by 0.976, I get 2. So this is doubled. This is double the original expected value. So when we've doubled all the prices individually, our mean, our expected value has already also doubled. So for the variance, we're going to have to do E of x squared. So that gives us £1 squared times 0.4 plus £1.80 squared times 0.16 plus £2.60 squared times 0.24 plus £3.20 squared times 0.2. So that gives us 4.588. So for the variance, we're going to have 4.5888 minus 1.952 squared. So our answer minus 1.952 squared, which gives us 0.778496. And for comparing that to the original variance, so if I divide that by 0.194624, I get 4. So this is 4 times now the original variance. So if we try and think about the relationships that we've just seen there, when we doubled the prices, the expected value doubled and the variance was multiplied by 4, and for when it was halved, the mean was halved, but the variance was a quarter of what it was. So we're going to have a look later on at how those link together a bit more. You can also be expected to talk about movements in the mean and variance. So we had a look at multiplication, now we're having a look at what happens when we add and subtract values from them. So now we have our ice cream driver again, who has Fun Friday, where he drops the cost of each one by 10p. So what is going to happen to the expected value? Well, we're expecting that it's going to decrease and if all the values are going down by 10p, hopefully that means that our mean will decrease by 10p. What's going to happen to the variance? Well, if you have a think about how spread out the values are, the difference between 50p and £1.60 is £1.10. The difference between 40p and £1.50 is still £1.10. So there's no difference there. So we're hoping that that's going to stay the same. Let's have a look at what actually happens though. So when we're calculating the new expected value, we're going to have, if I go back and do it the short way, where I've already got my probabilities typed in. So we're going to have 0.4 for our 40p, 0.8 for our 2 scoops, £1.20 for 3 scoops and £1.50 for 4 scoops. Calc, make sure you're set again, list 1, list 2, because we've got some frequencies as our probabilities, and that gives us 0.876. And remember, I copied over the mean before, which was 0.876, so I was correct that it does decrease by 10p. Let's have a look at what happens with the variance. So remember that we need to have e of x squared to start off with. So if I go back into my normal calculator bit, so I'm going to have 0.4 squared times 0.4 plus 0.8 squared times 0.16 plus 1.2 squared times 0.24 plus 1.5 squared times 0.2. So that gives us 0.962, which means for our variance, which is e of x squared, that 0.962 minus our e of x, our mean, squared. So that gives us minus 0.876 squared, and that gives us 0.194624. And if I scroll up, remember I copied it over for this part here, that's exactly the same as what we originally had. So we can see that when we add on or take off values, our variance isn't changing at all, but our expected value does change. I'm going to give you a second now to try the Now You Try, so please pause the video and give the Now You Try a go. So hopefully you've tried the Now You Try question. This time he is, due to global economy, he's having to increase his costs. He's doing this by 20p on all ice creams. And again, they haven't filled in this part here, but we can fill that in. So 50p add 20p gives us 70p, 90p gives us £1.10, £1.30 gives us £1.50, and £1.60 gives us £1.80 for 4 scoops. That's still pretty cheap though. So we've filled in the missing parts and we're trying to find the new expected value. So remember, we can do this the short way. If it's a show that question, you must use the formula. You must do it the longhand way. So that's going to give us 0.7, £1.10, £1.50, and £1.80. Make sure your set says list 1, list 2 because we're treating our probabilities as frequencies, and that gives us £1, 1.176. Remember, our original mean was 0.976. So we can see that it has increased by 20p. So it's increased by 20p. So when we increase the mean or decrease the mean, it increases or decreases by that amount. Let's have a double check of the variance. So remember, we have to do e of x squared. So back to the normal calculator part. So we're going to have 0.7 squared times 0.4 plus £1.10 squared times 0.16 plus £1.50 squared. £1.50 squared times 0.24 plus £1.80 squared times 0.2, and that gives us 1.5776. So for the variance, we're going to have our e of x squared, our 1.5776, minus our e of x, 1.176 squared, so minus 1.176 squared. And again, we end up with 0.194624, which is the same as what we had before. So adding on and taking off values does not change the variance. However, multiplying or halving our values does. Next time, we're going to have a look in more detail at what formulas go along with this to make things a lot easier. Thank you very much.